Welcome to the DIY Honda Garage channel. This troubleshooting guide is specifically designed for diagnosing and resolving the DTC P0453, which indicates a high voltage issue in the FTP sensor circuit of Honda Accord models from 2012 through 2017. The guide provides a systematic approach to identify whether the FTP sensor itself, associated wiring, or the PCM is at fault. Addressing this DTC promptly is vital because it impacts the evaporative emission control system, potentially leading to increased emissions and poor engine performance. We will explore step-by-step procedures ranging from initial system checks to detailed electrical testing and component verification. By following these steps, technicians can accurately pinpoint the root cause, whether it is a faulty sensor, damaged wiring, or PCM malfunction. The ultimate goal is to restore proper sensor readings, ensure correct circuit operation, and verify the integrity of related components, thereby maintaining vehicle emissions compliance and optimal engine function. In the initial phase, it is essential to verify the EVAP system status using the Honda Diagnostic System, also known as HDS. Before starting any testing, record all freeze frame data and snapshot information available through the vehicle's onboard diagnostics to aid in diagnostics and record keeping. Reviewing general troubleshooting guidelines ensures familiarity with relevant procedures and safety precautions, which is critical for accurate diagnostics. This step sets the foundation for all subsequent tests by confirming that the vehicle's diagnostic data aligns with the DTC and that no other complicating factors are present. Proper documentation helps when final verification is performed after repairs. Ensuring these preparatory steps are completed guarantees a systematic approach and improves troubleshooting accuracy. The second troubleshooting step focuses on verifying the persistent nature of the DTC by testing the system under operating conditions. After installing the fuel fill cap securely, you start the engine and set it to 3,000 RPM without load, meaning the vehicle should be in either park or neutral. This steady-state operation helps simulate conditions under which the high-voltage abnormality might manifest. During this test, monitor the DTC status via HDS, specifically checking if the P0453 code is indicated as failed, passed, or not completed. If the DTC status is failed, it confirms a duplicated failure, prompting further investigation. If it reports passed or intermittent, it suggests the fault may be transient or intermittent, guiding the next steps and perhaps further monitoring. Accurate observation ensures proper diagnosis and prevents unnecessary component replacements. This troubleshooting step targets isolating the fault by testing the FTP sensor circuit directly. First, you turn the ignition off to ensure safety while disconnecting harness connectors. Then, disconnect the FTP sensor's 3-pin connector, which is located near the rear on the fuel vapor system. To test the circuit continuity and voltage, you connect a jumper wire between terminals A and B on the connector, corresponding to the blue BLU and light green LTGRN wires. Restoring power by turning the ignition on while the jumper remains ensures the circuit is active for testing. The subsequent measurement of the sensor voltage with HDS allows you to determine whether the sensor or wiring issues are present, paving the way to identify whether the sensor itself or a wiring problem is causing the high voltage DTC. In this phase, measuring the voltage between specific test points ensures the power supply line is within expected parameters. With ignition in the on position, a voltmeter probes the voltage between test point 1, which connects to P-tank, brown wire, at the PCM connector, and test point 2, which connects to SG6 blue wire. A voltage close to 5.0 volts indicates healthy power supply and proper circuit operation. If the voltage significantly deviates, it could imply an open circuit or a fault in the wiring. Confirming the presence of approximately 5 volts ensures that the power supply to the FTP sensor circuit is adequate, allowing further diagnosis of the sensor and wiring integrity. This step is fundamental before proceeding with wiring checks or sensor replacement, as it verifies the basic circuit functionality. This step involves examining the continuity and integrity of the P-tank wire, which supplies voltage to the FTP sensor. First, turn the ignition off to prevent electrical hazards during testing. Jumping the SCS, sensor circuit switch line, using the HDS simulates active circuit conditions. Then, disconnect the PCM connector A, specifically terminal 42, which connects to the P-tank line. A jumper wire is used to connect the terminal to body ground, creating a closed loop to verify the continuity of the wire. Using a multimeter, you check whether current can flow through the P-tank wire. If continuity exists, it indicates the wiring to the PCM is intact. If not, you must repair or replace the open circuit in the wire. This test helps identify whether the wiring between the PCM and sensor is compromised, which can lead to high voltage DTCs. Similar to the previous step, this phase checks the integrity of the SG6 line, which is associated with the FTP sensor's blue wire. Firstly, with ignition off, you create a connection using the HDS to simulate active conditions in the circuit. Disconnect the PCM connector A, terminal 28, which is linked to the SG6 line, and connect it to the vehicle's ground via a jumper wire. You then verify continuity between the PCM terminal and ground with a multimeter or continuity tester. If you find continuity, the wiring pathway is intact, indicating no open circuit in this line. If there is no continuity, you need to repair the open or damaged wiring. Confirming wiring integrity ensures that signals and power are correctly transmitted, which is critical for accurate sensor readings and proper circuit function. The final step consolidates all repairs and confirms the system's proper operation. Reconnect all connectors securely, ensuring no wires are pinched or improperly connected. Using HDS, exit the Special Control System mode to return the vehicle to normal operation. The next crucial step involves resetting the PCM, which clears stored DTCs and allows the system to reinitialize with the new or repaired components. Once the PCM is reset, perform the idle learn procedure as specified by Honda to ensure optimal engine idling and sensor calibration. Finally, start the engine and observe the DTC menu to see if the P0453 code is cleared and the status is passed. This comprehensive verification ensures the repair is successful, the circuit is functioning correctly, and the vehicle's emission system is operating within specifications. Please like and subscribe to the channel. See you next time.